Great. Transcript is going, recording is going. Welcome everyone. Tonight we're gonna focus on chi-square. We're going to look at some hypothesis, and chi-square is basically looking at our hypothesis testing when you have two variables. So remember in our previous study unit 9, we looked at hypothesis testing when we looked at one variable. So basically chi-square is going to be a test that we use when looking at two variables, like we did with hypothesis testing in study unit 9. For chi-square, there will be a separate table that we will use. So again, those tables that you got in your TUT letter 101 in your study guide as well, we will use that again tonight to just look at certain questions that we will need to solve with a basic chi-square table. Again, it is a bit different, but you will, as we go through it, you will also see some similarities in the chi-square test again compared to your Z test and the T table that we're using. Okay, then just quickly, next week we'll do study unit 11. So that again is regression, and then we're actually done, which is scary. But then we'll do a few rounds of recaps, so that we get you ready for that last assignment, and then we will start prepping for the exam. I don't think there is an exam date yet. Last year it was at the beginning of the exam. So last year it was very early in the exam period. The year before it was again later in the exam period. So when we get it, we will see when it is, but there will be enough time if it is middle October that we will have enough time for you guys to do recap for the exam. But let's focus tonight on chi-square. Okay, so chi-square, there's a few differences that comes in chi-square compared to the hypothesis we did in study unit 9. Okay, so with chi-square, because we look at two variables, the null hypothesis and the alternative hypothesis will always be the same. So the null hypothesis, what it will state is the two variables are independent of one another. So your null hypothesis will always talk about the two variables being independent of one another, and your alternative will always be that the two variables are dependent. Okay, so we don't have here the one with variable is bigger than the other one, or it's equal to, or so. With this, we basically want to test if the two variables are dependent or independent. So our null hypothesis is always going to state the two variables are independent, And our alternative hypothesis is going to be that the two variables are dependent. Okay, and that is important to remember that, because when we get to questions, they might ask which one is incorrect, and one can say, well, the two variables are dependent. So they might just say the null hypothesis, two variables are dependent. And then we know that one is the incorrect one. So very important with this, the hypothesis is always going to look at the two variables, where the null hypothesis is looking at independence, and the alternative hypothesis is looking at dependence. Okay, then one difference between the t-test and the chi-square. Remember, in the t-test, we also do degrees of freedom. In this one, the degrees of freedom is calculated a bit differently. Okay, so what it actually tells us is, because we always gonna work on a table, that you're gonna see how many variables are in the one. So rows minus one and columns minus one. So let me quickly. So if this was the question, we are going to look at degrees of freedom in a while in this question, but there is two rows, so 2 minus 1, and there's two columns, so 2 minus 1. Okay, so your degrees of freedom is row minus 1 times column minus 1. Okay, so that is the second step that is a bit different from what we've done in the previous chapter, is your degrees of freedom is calculated a bit differently. Okay, then we still using normally the 5, 10, or 1% levels. And if we look at that in the table, let's quickly just show. We'll again later come back to it when we need to calculate it. But let me just quickly show you guys. So again, very similar nearly to the T table, where we had alpha. So here we also have alpha as one of the, in the right hand, you can see that that bit is alpha, and the rest is 1 minus alpha. So very similar to the T table. If you look at just there's for alpha, the rest is 1 minus alpha. So very similar to the T table, and you will also see that when we get to some of the numbers, also some very, very similar things in some of them. But so when we look at alpha, just as your T table that had the upper tail, where we could have just said alpha. So I think the chi-squared table is a bit nicer because it shows alpha, it shows exactly where it is. So it will be exactly the same if we need to work with an alpha of 0.1, 0.05, 0.025. It's all there. So when we get to it, it's actually quite a nice table to work with. It gives us actually a very easier way to handle it. Okay, so when we get to need to work out the critical values, this is what we're going to use. Then the other thing that, like with the previous work, we worked out a test statistic for your T or for your Z. So the same is, there is going to be a test statistic, but we work it out a bit differently. And I will show you also in one of the examples how are we going to do it. But for now, we just remember the formula. So what it tells us is that we're going to work out the frequency of the observed minus the frequency of the expected. That, so it's not a quick sum. That to the power of 2 divided by the frequency of the observed. But park that nearly for now. I'll show you when we get to an example how we're going to work it out. And when we have that, it's exactly the same, like, and let's just draw it a bit different, that it's at least seen as a bit different to the Z and the T table. But so when we then get to the last stage, we're going to have a critical value out of step 3. We're going to have a test statistic out of step 4. And then we will need to make a call again, like we did with study unit 9's hypothesis testing, where we needed to say we accept or we reject the null hypothesis. So again, that is what we will need to do. And they've made it a bit clearer in this one. So when the test statistic is greater than the critical value, we will reject the null hypothesis. So let's write it. So when the t-stat is bigger than the critical, then we will reject the null hypothesis. Okay, but we will also get back to this one as we work out questions. Okay, so, but what is nice is this is nearly 5 steps that we can follow, and in your study guides, and I hope I copied it into, I had it somewhere, so let me just, so in the study guides, this is nearly what they have in I think somewhere in the first few pages. And that is nearly what we're going to do every time. So we're going to check for, there's step 1, for the null hypothesis alternative. We're going to look for the degrees of freedom. We're going to basically work out your test statistic. The one thing that is missing here is the critical value. And then finally, we will make a decision. Okay, so, and I like this because this nearly also, it's a nice summary of everything in study unit Unit 10. Okay, so I'm gonna every time nearly just when we start a question, gonna copy this into the question so that we can the whole time reference it. So again, for you guys, it's a very nice one if you can again prep yourself when you're writing the exam, you have that against the wall nearly when you have access to it so that you don't even need to page through in your study guide. You actually have it printed somewhere and you can just look at it and continue. Okay, so and you are allowed to have it. So there's no reason why you can't print it for yourself and just make it easily available when you need to do the questions in the assignment and during the exam. Okay, so the best to nearly get this and to understand this is to go through a few examples. So let's look at some of the questions I've put in some of the previous assignment questions, so you guys will see there's some questions that's previous assignments. So it might be that one gets some of them again. So yeah, let's go through a few. It's a mixed bag of different questions. Okay, so they tell us in this question, in a contingency table, or if a contingency table has 4 rows, so 1, 2, 3, 4 rows, and 5 columns, so 1, 2, 3, 4, 5. How many degrees of freedom are there for the square chi-square? Okay, so we know degrees of freedom for chi-square is rho minus 1, column minus 1. So rows, they told us there's 4 rows, so 4 minus 1. And they told us there's 5 columns, so 5 minus 1. So we've got 4 minus 1 is 3, times 4 is 12. Okay, so you can also see they've got a few different things. So if you said 4 times 5, there was the answer. If you said 4 plus 5, there's the answer. But it's 4 minus 1 times 5 minus 1. So the answer is 12. Okay, so a nice one to get into because this is just a question. They didn't give you any information. We just needed to nearly work out what is the degrees of freedom. Okay, so we checked how to do that. They're not really going to ask you a standalone question on the null hypothesis or the alternative hypothesis, but it will be worked into questions like this. Okay, so let's add this information and then let's just see what they were asking in this question. So you can see they're giving us the contingency table. There's one variable that looks at A and B, and there's the other variable that says yes or no. Okay, we don't really have any other information about it. So and they then tell us the professor wants to test the independence, and we work with a 5% level of significance. So alpha is 5%. Okay, so the first question, the null hypothesis, is that the two variables are independent. The variables are independent. Okay, correct. Alternative hypothesis is the two variables are dependent. Okay, so now look at those wordings. So we used to not independent. So if something is not independent, it is dependent. So just be careful in a question like study unit 10 again, where they might use different words for independence. Okay, so not dependent means independent. So just be careful that we might mark that wrong because we were looking for not independent. Okay, so again, nearly back to those first few study units where, again, some of the English is they are going to try and trick you on some of those things. Okay, critical value. So if we want to work out critical value, we basically look at degrees of freedom, and we look at the alpha to get that. So degrees of freedom is rho minus 1. So yes, no means 2 minus 1. And A and B means 2 minus 1. So then we're looking at the degrees of freedom of 1, alpha of 5%. Very important here when we look at the degrees of freedom, never add the total as part of the rows or columns. Okay, we're looking at the options. So the options are yes or no, and the answers was A or B. Okay, so total does not count as an extra row or extra column. Only if it was, the answers was yes, no, and the third option of maybe, then it would have been 1, 2, and 3. Okay, but total, and again, that's sometimes how they catch you out, is they put in total, and sometimes we include that as part of the number of rows or the number of columns. So please never, we don't include the totals when we look at the number of columns or the number of rows. Okay, so critical value 1 and 5%. Let's make this a bit bigger. So critical value of degrees of freedom of 1 and alpha of 5%. So 3,841. 3,841. Okay, and what you will also notice, it's not alpha divided by 2 like we did in a t distribution. It is purely looking at alpha, and that's why they also make it clear in this table that that is 1 minus alpha and that is alpha. So it's not, there's not a two-sided inverse, so you don't divide by 2, so it is purely alpha, and there you can see also it's purely alpha, not alpha divided by 2 like in your your t distribution. Okay, so that's another slight difference between this and a t distribution as well. It's not alpha divided by 2. Okay, then let's work out an expected value. So expected value of yes, so it's the row total, which is 65, times the column total, so B, 70, divided by the total, the N. So let's see quickly on the calculator. So 65 times 70 divided by 145. So what I get is 31,38. And this expected that they gave us is 25, which is incorrect. But let's just look at so they got that 25. So this 25 that they are referring to is for observed. Okay, so there might be questions that they ask us for observed and they expected. So the table that you get is all observed values. Okay, so that is all observed values. Then sometimes what they will do is give you another table with expected values, or they might give you in a table, and we've got the example like that, where the expected values might be in brackets. Okay, but they will then tell you that. So else the table that you're getting is a table of observed values. And you can basically see this is very similar to what we did in study unit 4 when we looked at probability. We also had a table that was 2 or 3 variables, and we did probabilities of that. Now we're just taking it a bit further to test for that independence. Remember, at that stage, we test for independence with probabilities. So here we test the independence with another type of measurement. Okay, so we're not using probabilities. Now we test it with this chi-square method. So again, we're testing basically for the same thing, but we use a different methodology. Then the last question is just, so they said, suppose you have the test statistic that is 4.5455. So at the 5% level, the null hypothesis is rejected. And remember, we said out of our, where was that? We said we'll reject the null hypothesis if a t is bigger than the critical value. So let's look. 4.5455 is bigger than the 3.841. So your t stat is bigger than your critical value. So we will reject the null hypothesis. Okay, so again, they have given us now enough information with a critical, they've given us for 5%. If they haven't asked us to work out the critical, you could have still worked it out in question 5 because they have given us enough information to work it out. Okay, so that is just again, so we covered H0, H1. In a sense, we covered degrees of freedom because we needed to get to a critical value. We've done an expected value, and then we have worked out with giving us the test statistic what we would have done, reject or accept. Can this nearly they can all ask you in one question. So the whole study unit can be asked in one question for you guys. So I think that is also important to note. So in the assignment, there will be 3 or 4 questions. While assignment 5 will be on study unit 10 and 11. So 4 or 5 questions from each study unit again. But in the exam, 1 or 2. So a lot can be asked in one question like this. Okay, so let's look at a few extra things. So now there's no table. Okay, so they just tell you in a test for independence of 2 variables, one of the variables have 2 possible categories. Let's say the rows have 2 and the other has 3. And so first let's work out degrees of freedom. Yes, question.
Sorry, Gene, I didn't want to disturb
No.
you. The previous question, just the last part, I do not understand how we go to that answer.
Okay, so I think the important thing there is just to not, so it's a bit different from when we did the Z and the T distribution. So the thing that we can nearly remember when we work with chi-square is when that T stat that we're working out, if that is bigger than your critical value, so if that is greater than your critical value, we will reject the null hypothesis. Okay, so that is nearly the rule with chi-square that we must remember. So when you look at this, the t-stat, so we could have worked it out, but they gave it to us. So that t-stat was 4.5455, and that is bigger than the critical value of 3.841. So by that definition, then we can reject the null hypothesis. Okay, does that make a bit more sense?
Okay, it does. It does. Thank you.
Okay, cool. And again, I think it is important because they're gonna, here they ask it, if you look at all these questions, everywhere they do put that in. It might be that we never get to it, and there is one of the other ones as the right or the incorrect option. But I think it's important that we go through it so that we can every time see if it is true or not. Okay, so here, no table at all. They give us a few snippets. Then, so the first thing I would do is to work out degrees of freedom, because that is really the easiest one to work out. So we know there's two rows, so 2 minus 1 and 3 minus 1. So I would always go in a question and first look if I can work out degrees of freedom. So it will be 1 times 2. So degrees of freedom is 2. Okay, degrees of freedom. Okay, so that is the incorrect one. Okay, so again, I always start with the easiest ones. So what I would start off with is degrees of freedom. Then I would check the two hypotheses. So null hypothesis, always independent. Alternative hypothesis, always dependent, or the other word is not independent. Okay, so that is, so here we could have seen that is correct and that is correct, but yeah, we already know which is our incorrect one. But again, I want to show you guys how to get to the other answers as well. Okay, then they tell us, suppose the T-stat is that. Okay, so first let's work out what is the critical. So degrees of freedom is 2. Remember, the alpha is 5%. So back to the table, 2 and 5. So 2, again 5. So 5,991. Okay, so critical value is correct of 5,991. So then remember, like we did in the previous, if T-stat is bigger than critical, we reject the null hypothesis. Okay, so that is, so let's check. T-stat 3,456. Critical 5.991. Okay, so T-stat is not bigger than critical. T-stat is actually smaller. Okay, 3.456 is smaller than 5.991. So we actually do not, in this case, do not reject the null hypothesis. Okay, so that is the rule, but we can now see that your T-stat is actually smaller than your critical, so we do not reject the null hypothesis. Okay, so a bit tricky again. So let's see what was that option. Fail to reject, so that means we do not reject. So again, fail to reject, do not reject, or they could have said, if we do not reject the null hypothesis, we accept. So again, a play of words for some of these questions, but that would have then also been correct. So what I would normally do is, and again, you guys are allowed to write that down. I will just check again for my notes, and I will send on our WhatsApp group an update of all the study units with the notes. And I will just include some of these that we have it included in there when you have a set of notes that have everything being together again. Okay, let's look at another question like this. So here they give us a table. They give us some of the information. Okay, so we will be able to get all the information as we complete it. But I thought, okay, but let's first, we need to find the correct one. Before we start with anything, let's look, degrees of freedom. Okay, so it's 2 employees, so there's, the one is 2 minus 1, and the quality is acceptable or unacceptable. So there's 2 options for that as well. Okay, so degrees of freedom, 2 minus 1 is 1, 2 minus 1 is 1. So the degrees of freedom is 1. Okay, which one is correct? Let's look if there's a degrees of freedom. Okay, degrees of freedom is 1. Okay, so in this instance, we are still going to go through all of the other ones, but in the exam, where your exam will be timed, please don't look for the easier ones first to do, because we don't want now to first complete the table and then you start at the top and now we work out a lot of things. There's a few things that I would nearly say, okay, let's first look degrees of freedom. Okay, cool. We don't actually need to waste 5 minutes on it. This was an easy one to check and move on. Okay, but let's still just look at the other ones, why they are wrong. Null hypothesis, so null hypothesis, the nearly we get into the rhythm. Null hypothesis is independence. So they say null hypothesis is dependent. So that is why that one is wrong. So we always test with the null hypothesis independence. Observed frequency of acceptable and employee John. Acceptable and John. So we're looking for this value. Okay, so that value we're going to get by saying 950 minus 265. That will be the observed value. So 950 minus 265, that is equal to 685. Okay, so very close. So one can easily make that mistake to say to see it as 685 or to see it wrong, but so very easily one could have made that mistake, but we get it, the 950 total minus the 265 gives you the observed. Expected frequency of acceptable and Peter. So acceptable and Peter is total of acceptable, which is 950, times total of Peter. So let's quickly see if that's 1,000, that's 700. The total of Peter is 300. So 950 times 300 divided by the total N, which is 1,000. Okay, so let's see. So that's the expected value. So 950 times 300 divided by 1,000 is 285. Okay, so that one is also wrong. What that 265 is your observed. Okay, so the 265 was the observed value. The expected one is 950 times 300 divided by 1,000. Okay, then they tell us, suppose, okay, so let's again look at T-stat. So if T-stat is bigger than critical, we reject the null hypothesis. And so they tell us the T-stat is 40. Okay, so let's see, 5%, 1 degree, so we've done that already. 5% 1 degrees is 3,841. So T-stat is bigger than your critical. So 40 is bigger. So we will reject the null hypothesis. They tell us the null hypothesis is not rejected. That's what's wrong in this one. So that is why option 5 is also wrong. Okay, but degrees of freedom was the easy one to work out, but also very important to know how to work out the rest. Because again, it might be that for some of you, um, you get to do, it might be that it's one option that you need to pick. Remember, there's 2 or 3 options again in the assignments. It might be that one of the other options is that you need to work out the observed or need to work out the expected. So always good to work these out. So every time we will go through the list in any case. Okay, so here is another one, and let's see if I can just make it a bit bigger. Um, okay, so they give us options or the question. So we get for observed, and that is our 4 numbers of observed. Sorry, let's just need to work with it. So that is your 4 numbers, and we get the expected. And we now need to work out this chi-square. Okay, so remember the formula, and we can paste that formula back in so that we don't make a mistake with this. And I'm just going to look at that component because that's all that we need for this one. Okay, so that is what we will need to work out. So we have observed value. Let's just quickly observed minus the expected. That to the power of 2. Remember the sum of that plus 23 minus 25.49 to the power of 2 plus, so that was that one, then and let's just give some space here. 10 minus 12.49 to the power of 2 plus 36 minus 33.51 to the power of 2. And each one we will need to divide by the expected. So that one is divided by that. That one is divided by the 25.49. So this is a very long exercise. So what I normally would do, so now you need to work out that one, that one, that one, and that one, and we will get an answer. Why is my screen frozen? Okay, so what I did is here is the formula for that, but this is wrong. Okay, so in one of, I think, the study guide or the other one, so this formula is the wrong formula. So just be on the lookout. So this question 10, I don't know if it's in the study guide or if it is from that extra book with questions in. So remember, this is your formula. So what they've done, they printed that wrong, but these ones are right. So it should be 12 minus 9.51 to the power of 2 divided by 9.51. Okay, so not, there shouldn't be brackets. There shouldn't be brackets. It should all just be brackets at the top. So that is just, so if there is mistakes like this in your study guide, just be aware that the formula we're actually working with is observed minus expected to the power of 2 divided by expected. Okay, so it's not, it should be there and not there. Okay, so it might be in a few questions in the extra study book that you got that they've made that mistake in the printing, but then when you get to the answers, that is correct. Okay. What I normally would do is I would do this in Excel. So let me quickly show you guys how I would do it. So let's put in 12, 23, 10, 36. So we've got the expected. But what I would actually do is, because you don't always get that, let's put in a formula for you guys that will make it work so that it, but if I don't give it to you the expected, because I don't always give you the expected numbers, that will work out. Let's quickly see. That's supposed to be cool. Okay, and let's just check if we not do this. And so when you guys can use this for other questions as well, then you just replace those numbers and this will automatically change. I will send this to you guys on the WhatsApp chat as well, so that you have it. So what I then normally do is, so we know the formula is for observed minus the expected, the power of 2, and that we will divide by, and again, it doesn't, so I would not on the day of the exam now suddenly, when you get a question like this, do it. But if you have Excel spreadsheet that is set up beforehand, then it is easier. But to do it on the day of the exam, it will just take a lot of time on your side. So let's quickly just open up where those questions was. So you can see the 0.64 of 654, so very close. 2.2439, 2.243, 0.4964, 49 close, 0, okay, so if we sum all of that, very close to that number that we got. Okay, so again, this is something that I will share with you guys that you can work with. And it's just because those numbers are not rounded off, but check if we put that in, then you can see it's exactly the same. Okay, so, but I'm gonna just so that you can use it in the exam or in your assignment. So I will share this as well later tonight, when I send the presentation and the recording, that you just have it as a tool if you want to do it. But yeah, we also did it the longer way. It is just easier to make a mistake with your calculation if you do it the longer way, but nothing stops you from doing it this way. Okay, so again, you guys can decide if you want to use Excel or not, versus if you want to work it out on paper. Okay, so that would have been our correct answer. Oh, shucks. Where is that question? Okay, so I'll put in that question as a different example for us for one of our other sessions. I don't know what the question is. So this question was from one of the assignments from 2 or 3 years ago. So which one of the following statements is incorrect about a chi-square test of independence between two variables? Okay. The test statistic has R minus 1, C minus 1 degrees of freedom, where R is the number of rows, C is the number of columns. Okay, so that is correct. That is that one that they're referring to. The observed frequency for each cell is equal to row total times column total divided by n. Okay, row column divided by n, but they're using the words observed, so that's wrong. So if we were talking about expected, then it would have been right, but they're referencing observed, so that is the word that is wrong. So it's not about the observed frequency. The observed is the one that you get. The expected one you work out by row total times column total divided by n. Okay, so observed is what you get. Expected is with this formula. Okay, so option B is incorrect because it's the expected frequency that we work out with that formula. Okay, but let's just look at the others as well. The two variables are qualitative. It is correct because we just like this male is qualitative, it's not quantitative. Female qualitative. Enjoy shopping, yes or no, again qualitative. So everything with chi-square is looking at qualitative data, so that is correct. Then null hypothesis is two variables of independence. Null hypothesis is independence is correct. If the observed and the expected frequency for each cell are equal, then the test statistic will be equal to 0, which is correct. So if observed and expected is 0 or is equal, you will have, so if it was, let's say 26, you've got 26 minus let's just quickly, I just want to save this. I am worried that it might crash, so let's just, okay. So 26, let's try it here. 26 minus 26. So they say if observed and expected is similar, that to the power of 2, the 26 minus 26 is 0, so then it doesn't matter. So if for each cell, whatever the numbers are equal, we will have 0 plus 0 plus 0 plus 0. Your test statistic in the end will also be equal to 0. Okay, so a bit more of a theoretical question with option 5 as well, but you can get theory in either question. So I think this is important. So they tested something on that, they tested that, they tested that, and they tested something on your test statistic. So the only thing that they didn't really in this one test on is if you will reject or not. So again, very easy to nearly cover everything in this table by one question. And this one was now not even numbers, it was just theoretical type question. So that's why I wanted to include it, so that you guys can just see both options. Okay, so this also came out of one of the assignments. So I think this was the first online assignment nearly that was done during COVID. So let's look at what they ask us. So the following 2x3 contingency table contains observed and expected frequencies in brackets from a sample of 364. Calculate the chi-square t-stat. Okay, so again, what we now need to do in this one is to say 55 minus 4254, that to the power of 2 divided by 42.54. And then you need to do it for all of them. So I would rather do it in Excel again. Let's change this a bit. Let's just insert, so 55. Okay, so that for now will be all wrong because we're only looking at the two numbers. We will update now. So let's just make it, I'm gonna do that. Let's make it a bit nicer. So let's put in totals when it is easier in this calculation to work with the totals. So let's do that. Then again, you can use this one if you want to. So let's clear that all. Okay, so it was that total times that total, and it is easier for you guys. Just do that. Okay, so then we'll check now what is happening. So that's right. Okay, so that's right. That's right. So let's do that. Okay, so then that one quickly, let's just that times that. Okay, yeah, both of them moved. Okay, so I will again share this. Okay, so let's see if we get something that we can work with. 9,4. So Okay, 9,40. So there we have it, 9,40. Okay, so I'll rather share this one is a 2 by 3 table. This one was a 2 by 2. So again, you guys can choose which one whenever you need it to use. So the 2 by 3 table, the 9.4 is our answer. So D is. So you can go and check now and work it out. So each of those ones you can, when I send it, you can check if you get the same answer. So that you just, if you want to practice it without Excel, you can, but you can then sense check or answer in Excel for you guys. Okay. Okay, so that was, and this is, it's not tricky, but it takes time. So that's, I don't like this question because it takes time, and you guys don't have a lot of time in the exam. So that's nearly, I don't like a question like this if you get it in the exam. If it is in the assignment, which you get enough time to complete it, then it's not a problem because it tests if you can work it out and understand it. But to get something like this in the exam and you're not using Excel, which is also fine, but it does take time. So I normally don't like it when they put it in the assignment, in the exam. So let's hope they don't do it this year as well. But it will most likely be in the assignments. Okay, then the last one. So this, oh, this is exactly the one that we have done with the 4 rows and the 5 columns. So I'm not gonna, okay, let's quickly just, so we know the formula is column minus 1, row minus 1. So columns is 5 minus 1, rows is 4 minus 1. It's 4 times 3, which gives us 12, just to recap that. Yeah, so that's chi-square. So chi-square, basically, the difference between that and study unit 9 was study unit 9 tested, you were working with one variable. That variable was a quantitative variable, and what that did was to say, but in study unit 9, we got a number of the mean. We wanted to check if a mean is the same as the population and those kind of things. In study unit 10 with a chi-square, we are looking at two variables. And we are trying to work out if these two variables are independent from one another. Okay, so a big link between this and study unit 4, where we used probability to see if two variables was independent from one another. Here we use the chi-square, and then we use the chi-square test to see if two variables are independent from one another. And then it is, as we did with the T and Z when we were doing the hypothesis testing, for the mean or the proportion. For categorical data, the chi-square, we follow the same process nearly. The first step is to identify your null and alternative hypothesis. That's exactly the same that we did in study unit 9. Remember, if it was a t distribution, we went to the t table, so we needed to have the degrees of freedom. So the same in this one, need to look for the degrees of freedom. Then, as in study unit 9, they tell us what is the confidence or level of significance. And again, we'll use the traditional, if you look at alpha as 5, so that is 95, 90, and 99, so 5, 10, and 1%. As in study unit 9, where we calculated a t-stat by using the formula of z is equal to the same we're doing in chi-square. We're looking at a t-stat, but yes, it is a bit different in how we calculate it, but the same principle is working here, that we need to work out a t-stat. And then the final one, like in study unit 9, we need to make a decision. So we need to say if we reject the null hypothesis or not. Okay, and the big difference nearly is in this rejection, where with chi-square, the only thing that we're nearly looking at is it dependent or not? So if the test statistic that you calculated is bigger than the critical value, we reject the null hypothesis. Okay, most of the time, as you guys would have seen tonight, is they give us the critical value sometimes. They give us the t-stat, and then you need to make a decision on the hypothesis if you're going to reject it or not. Yes, sometimes they tell us again, so there they told us the critical value. It might be that one of them, like the critical value, is wrong, but to work it out, we go to the chi-square table. They will tell you what that alpha is. So everything we did tonight was actually a 5%, but they will tell you that if it is the 5% or if it is 1%. So if it is 1%, there is the 1%. If it is 10%, there is the 10%. Okay, then the big difference between chi-square and t is nearly, you can see it in that as well. So the chi-square, when we work out that degrees of freedom and we need to work out the critical value, the important thing is here, it is the alpha, where if we were at the, oh, and they don't, was hoping that they did it here, but remember when we look at the t, we look at the degrees of freedom, and we look at alpha divided by 2. Okay, so that's the big difference between the two, is that it is here, it is just for alpha, it's not alpha divided by 2. So that for me is one of the critical things. Yes, the degrees of freedom is also a bit different. The degrees of freedom, we work out with the formula of row minus 1, columns minus 1, where degrees of freedom in your T distribution was n minus 1. So just remember that's also a difference. But just we were so used to always looking at alpha divided by 2 when we were working in the T distribution. So just be very careful with the chi-square. It is just alpha. Okay. Okay, so that is it for tonight, everyone. We will have another session on Sunday morning. So I will send out that link onto the WhatsApp group for Sunday morning. And then next Thursday, so Sunday morning will be a recap of this study unit 10. And then next Thursday, we will do study unit 11, with a recap again that Sunday of study unit 11. And then we will do 1 or 2 recaps of both study units for your assignment 5, and scary when we start prepping for the exam. The exam last year, I think